All right, here we go. Section 10.2.2. We're talking about tree diagrams again, but now we're talking about tree diagrams and conditional probability. Okay? Yesterday's lesson, or actually 2 days ago, we talked about tree diagrams with independent events. Today, our events are going to be dependent, and that's sort of what makes them conditional probability. So this is the example that we're going to work through. It says, Devin is going to draw 3 cards, one after the other, from a standard deck. What is the probability that she will draw exactly 2 hearts? Okay, so we're going to set up this situation with a tree diagram. She is drawing 3 cards. When she draws the first card, we have to decide, is she going to get a heart or not a heart? When she draws the second card, we have to decide, is she going to get a heart or not a heart? Same thing when she draws the third card, right? So if we set up our tree diagram, her first card will result in drawing a heart or drawing a card that is not a heart. When she draws her second card, she will either draw a heart or not a heart. And of course we have to represent that off of both outcomes from the first card. And then we have her drawing a third card, and we have to decide, is she going to draw a heart or not a heart? And we have to represent this on each outcome from the second card. Now we're going to go through and we are going to label each branch with its probability. And this is where the conditional probability with dependent events comes in. Let's start with our Devin's first choice of cards. We know that a standard deck of cards has 52 cards in it, right? It has 4 suits. It has cards 2 through 10, Jack, Queen, King, Ace in each suit, right? So we want to find out what's the probability that she gets a heart on her first card. 13 out of 52. What's the probability that she does not get a heart on the first card? 39 out of 52 that she does not get a heart. Okay? Now we move on to the second card. We need to now find the probability that Devin chooses a heart on her second card. So, given the fact that she has chosen a heart on her first card, if we're working at the top of our tree diagram, what's the probability that she chooses a heart on the second card? So here it's 12 out of 51. And of course, the probability that she does not draw a heart on the second card, so here we get 39 out of 51. Now let's go to the bottom half of our tree diagram, where we are now working on the condition that Devin did not choose a heart on the first card. We have to find the probability that she chooses a heart on the second card. So the probability here is 13 out of 51. Now we have to find the probability that she chooses a card that is not a heart, assuming she chose a card that was not a heart on the first card. So this is 38 out of 51. Now we move on to the third card that she chooses. Let's work on the top part of our tree diagram. We're going to start along the path where she chose a heart on the first card and a heart on the second card, and now we have to find the probability that she chooses a heart on the third card. So this probability is 11 out of 50. Now we're going to work along the path that she chose a heart on the first card, a heart on the second card, and what's the probability that she chooses a non-heart on the third card? So this probability is 39 out of 50. All right, now we go along the path that she chooses a heart on the first card, a non-heart on the second card, and we have to find the probability that she chooses a heart on the third card. So this probability is 12 out of 50. Now we have to find the probability that she chooses not a heart, right? So she chose a heart, then not a heart. Now the probability that she chooses not a heart again. We get 38 out of 50. Now let's work on the lower part of the tree diagram. And we'll go along the path that she chooses not a heart, then a heart, and we have to find the probability of choosing another heart. Here we get 12 out of 50. Now we'll go along the path not a heart, then a heart, find the probability of not a heart. We get 38 out of 50. Now we'll go along the path that she chooses not a heart on the first card, not a heart on the second card. What's the probability that she chooses a heart on the third card? 13 out of 50. And then our last path is that she chooses not a heart on the first card, not a heart on the second card. We want the probability that she chooses not a heart on the third card. 37 out of 50. So what you've now seen is that each subsequent probability is conditional upon the previous probabilities or the previous outcomes, right? And that's exactly why this is called conditional probability, because you are finding a probability based on a specific condition. So we are finally ready to actually answer the question after all that work. What is the probability that she will draw exactly 2 hearts? Well, we first need to identify how many paths result in her drawing exactly 2 hearts. So let's do that. We have a heart on the first card, a heart on the second card, not a heart on the third card. That would result in exactly 2 hearts. We have a heart on the first card, not a heart on the second card, a heart on the third card. That would result in exactly 2 hearts. Then we have not a heart on the first card, a heart on the second card, and a heart on the third card. That would result in 2 hearts. So next we're going to find the probability of each of those pathways by multiplying the probabilities of the branches. So we've taken out our calculator, we've multiplied the probability of the branches in each pathway together, and we see that the probability of the first pathway is 0.046 rounded. The probability of the second pathway is again 0.046, and the probability of the third pathway is again 0.046. So to get our final probability that Devin chooses exactly 2 hearts, we add 0.046 plus 0.046 plus 0.046, and we get 0.138. So here's the actual definitions of dependent events and conditional probability. 2 events are dependent events if the occurrence of one affects the probability of the other. And of course, in our example, when Devin would choose a card out of the deck, that would change what is left in the deck and thus change the probability of the next card that she would draw. The probability of an event A given event B is called conditional probability and is denoted by the notation that you see here, the probability of A given B. That's not a division symbol, it's not a division line, it is just a vertical line. It's the notation for conditional probability. Now, of course, in our example, again, Devin was choosing 3 cards. Now, the probability of Devin choosing a heart on the second card, given that she had already chosen a heart on the first card, is an example of conditional probability. And finally, we have our multiplication rule. Again, same as independent events. We would take the probabilities of each branch, multiply them together to get the probability of the entire pathway or the entire outcome.